but if you might need to actually
go
a little
past
further
it.
with the ship, yeah.
Good idea.
Okay. What speed would you guys like to move at?
Well, why don't you just do a move, do like a 50-meter move. Like how far are we from the ship right now? How far is Argus from
you
the
guys
ship?
are 55.
Yeah, let's do a 50-meter move on the same bearing that they were going at before.
Copy. Bridge nav.
Look at how tall that thing is.
Oh, wow.
Yeah.
Is that a...
Can I get a step of 50 meters at the same bearing? That's correct.
What might that be, a sea pen?
I don't know. Possibly some. It looks like it's polyps, like a coral.
Right.
Yeah.
Yeah.
And the one next to it's a little sponge.
Oh, is that? I've been seeing a few of those. It's like a fine china teacup on a stalk.
Yes, they're called stocked sponges.
Okay.
Mm-hmm.
And a few of our viewers have been noticing there's been some amazing glass sponges as well.
Mm-hmm. Yeah, I think that stocked sponge might be a glass sponge.
Okay.
Bridge nav. I get a bearing change of 020.
And then the yellow are stocked crinoids.
What type of animal group are they? Are they a coral?
Uphill.
Crinoids? No, they're their own.
Okay.
I have to look at what else they belong in,
Right.
but they can actually move, which is kind of cool.
Oh, that's interesting.
Like? Are we going to be going downhill or uphill?
Yeah, we're going down.
We're going to be going down the whole time.
We're going to go.
Yeah, they're a phylum of their own. They're an echinoderm.
Okay.
So brittle stars and
We're the high feature
sea stars also fall in that
right
classification. But yeah, we've seen them jump before, which is kind of cool.
Oh my word.
Is that a black coral down bottom left?
Bottom left. Oh, I missed it.
Might be. Still there.
Yeah.
Might be a crack in the rock.
No, I saw that. It looks like it might be a black coral.
Yeah.
Oh, we've got a wonderful question on Nautilus Live. Where does the name glass sponge come from?
It's actually a type of sponge, so it's because their spicules are made of silica. So they're actually really tough to work with. If you take a sample of one, you have to be very careful because the spicules are very fine and they'll go through gloves. They go through bags, and it's very painful to have them break off in your fingers. But they're experts. We have really good sponge researchers who have identified sponge from our different cruises, and they look at the spicules. A lot of the identification comes in looking at the spicules under microscopes and the forms of them.
As a bit of a newbie to oceanography, I'm just amazed at the jump and change in the biology from leaving the hydrothermal vent fields on the side and coming to these basalt lavas. It's like an underwater garden.
Yeah, I think there must be higher flow here. I don't know if Josh or Jess have noticed more current, but those types of organisms need a hard surface to stick to, and they also need a lot of current to have food move past them.
Right.
So
and also, it's wonderful to just kind of get the impression of how much accumulated volcanic activity we're looking at. This is just amazing, all of these eruptions, layer on layer. I'm sorry, I'm going into full-on enthusiasm mode here.
No. And it is incredible to think how much production there was out of this seafloor one time. It'd be incredible to see it happening.
Yeah.
SLX, I think when the ship gets to its position there, then you could start the tracking line.
Copy.
move. Yeah.
What speed would you like?
We've been doing 0.5.
0.5 knots.
They were doing 0.5 before?
Yeah.
So-
Nicole, when we're going down slope, I was told before that they weren't turning to see the slope, but it looks like we're gonna be going down slope the whole time.
Yeah, so the
That's
best you
pretty
can do to see the seafloor is, I think what we want to do is just, if you need to go a little slower because we're going down slope, it's up to you.
Okay. So you want us to turn to face the slope and then and kind of back down? Is that the?
We'd like to see the seafloor, so if you have to turn, then let's do that. But I leave it to you guys to decide.
Roger. Then I would say probably we should go a little bit slower going down slope then, maybe like 0.3.
Yeah,
Josh?
it looks, we're headed off this direction, right?
That's correct.
Yeah.
Yeah, that's really steep there. We
Mhm.
may not be able to. We might have to just kind of hop off and then go down and catch it down there. That's a pretty steep drop.
Okay.
So when you say 0.3, Josh, is that meters per second?
No, that's 0.3 of a knot.
Okay, thank
Yeah.
you.
Bridge nav.
Hold on. You want to confirm the bearing with us real quick?
Stand by.
You want to confirm the bearing with us?
Stand by. I'm gonna call. Stand by, please. I was gonna move the ship at bearing 295.
All right, 295.
295. Track a line at 0.3 knots.
Okay. And where's the? Can you just show the next waypoint that we're going to? Just as a visual confirmation.
We're right here. Waypoint's over here.
Okay.
Can I get a? Can we track a line at bearing 295 at 0.3 knots?
Wait.
We'll be transiting for over a kilometer. This is nav, go ahead. Copy that. You guys be able to fire up Norbit when you get the chance?
Sure. Okay, it's on.
Norbit and Ethernet bottle are up.
So for those of you following on Nautilus Live, we are currently exploring with Hercules, I believe almost just shy of 3,000 meters below sea level, something like 2960.
2945 right now.
Cool, thank you. And we've actually taken a bit of a new direction this evening. If you've joined us on earlier dives in this cruise, we've been exploring the hydrothermal vent systems of the Gorda Ridge. We're now undertaking a 1 kilometer long geotransect across the seafloor, actually heading toward the main axis of the spreading center on the Gorda Ridge. This is where the Pacific and the Gorda plates meet and are slowly pulling apart from each other. The aim of this transect is to essentially collect video data that you're seeing, and from that the scientists ashore will look at the sediment accumulation over these pillow lava formations and use that to estimate the age of these formations. So we've got about 1 kilometer of this transect across the seafloor, and it's a wonderful opportunity to see quite varied and diverse deep ocean creatures. We'll do our best to keep up with you guys in identifying them. Sometimes, as you can tell, it's a challenge for us. But yeah, just a wonderful evening ahead of us.
So Josh, when we come about to 395, we'll have to take out that 6-8 wrap.
Right. Okay.
295.
295.
295.
I'll be turning the right. I'll be going to port, so it'll work.
Roger. Sorry, did I say 268? Because things get confused.
That looks like we're
Looks like we're kind of stopped.
at the top of the hill.
You're at the top of the hill.
Yep. It'll take a little bit for us to
Start swinging.
get rolling. Yeah, it might be pretty hard to, like this is really steep here, right?
Yeah.
So it's going to be pretty challenging to fly backwards. You could try to, you might be able to angle it or something, but I mean, jump off will be down here in the flat and then
Okay.
going.
And once we reach the flat, we can probably increase the speed a bit.
Yeah, we can kind of judge it as we're going.
A wind spiked up to 26 knots.
Roger. Yeah, that's a good thing to keep an eye on. Nice.
I believe the thruster's at the limit.
Roger. Let us know if they start to fall backwards or
Copy.
can't make any headway on this.
So I was just going to throw a quick question out to the front row if they've got a moment. Just a couple of our viewers on Nautilus Live were interested in the conversation you were having. And what's the difference between a ship move and tracking a line?
So a ship move would be moving the ship in increments of, let's say, 5, 10, or 20 meters. And then tracking a line is going at a specific heading, or bearing, rather, at a certain speed. And we keep going at that speed over in that direction until we tell the bridge to stop the ship.
Okay. And so the three of you, the ship, Argus and Hercules, all move in step?
Right now we're moving, we're tracking a line.
Right.
But we move together, that's correct.
Yeah. That's cool. Thanks, Alex.
Nicole, I'll get us set up and then I'll re-look at the seafloor again for you.
Copy that. Yeah, I think it's, Alex, do you know what those contours are at that cliff? They're 5-meter contours?
They are 5-meter contours.
So I think it's about a 50-meter difference between the step around and the next step down.
Roger.
I think.
It's a 50-meter drop at about over 10 meters.
Yeah, we're gonna lose sight for a bit.
Pretty much a wall.
Yeah. That's steeper than the other one, I think.
Mm-hmm.
I'll just stay on 295 and
Yeah, and I'll
you can
change
stay
my
and
heading.
play around in there, view.
Yeah. Okay. Try to maintain this heading. Nicole, does this heading work for you, or do you want to see more seafloor?
This is okay.
So if you're watching on Nautilus Live, I just want to take the opportunity to say hi to those of you watching around the world. We've got people joining us from all over North America, the United States and Canada. Scandinavia is well represented. We've got Sweden, Finland and Denmark, then down through Germany, United Kingdom. We always have a great core of viewers in Australia and New Zealand. Quick hello to China this evening and to our friends in Hawaii. It's great to have you all watching with us.
Change my Z bias a little bit.
Should I slow the ship down?
No.
No, you're good. I'm starting to move. I'm just getting set up.
Get going.
Thanks again to Nautilus Live for your shout-outs for the countries I've been missing. So, good evening, Armenia. Hope you're enjoying the show. So it can be difficult to get a sense of perspective, but Josh, you mentioned this is a 50-meter drop in 10 meters of horizontal length?
Yeah, that's what Alex was saying, so it's pretty steep.
Yeah.
And then it'll flatten out after that. We'll probably turn and kind of get into that same mode we're in before. We're just kind of letting Herc lead and Argus follows.
Cool.
And we may, if it gets too steep, we may have to just come up and shoot down to the bottom and then keep going. See how we go.
Is there any way to get the black, what is that down there at the bottom of the screen?
IGT?
No,
oh yeah, they're on the
not.
porch. Okay.
Yeah, unfortunately. I mean, we can tilt up and zoom in if you want to do that.
Well, there's
I think they
more visuals of the seafloor
yeah,
though.
yeah, they probably want it wide.
Wide angle, yeah.
Yeah, wide angle and kind of low angle too. So.
Yeah.
Are there any cameras on the port side other than the Niskin bottle?
Nope.
No. Fortunately not.
Can you see the port
Oh
side?
yeah.
Okay.
No worries.
In case there's
Big rock?
Mm-hmm.
Yeah, no worries. And if anything, if it gets too steep, you can also turn more and face more, but.
Another great point on Nautilus Live, and you're right that GPS doesn't work underwater. The ship is positioned on the surface using GPS antennae, but then what it does is it works together with the ROVs. The ROVs, I believe actually, is it new this year or 2 years ago? Now in the ultra-short baseline, the ROVs are actually pinging to the ship and pinging with a slightly increased regularity than before.
You're approaching the cliff.
Roger. Thank you.
Yeah, previously, well, we had two kind of systems running before where we were sending a responder signal to Herc and then using the transponder mode, which means that the ship was chirping to Argus, and then once the transponder heard that signal, it would chirp back. But it's a little more accurate in the timing in the responder mode, so we set up a dual responder where they're both timed just a little bit off each other,
Right.
to each vehicle, and that's helped improve our accuracy when we're going deeper. So the way these systems work is they work in a percentage of the accuracy is a percentage of the slant range.
Right.
So essentially, the deeper you go, then the less accurate that it is, because you've got all this distance that's listening for between the ship and the vehicles.
Uh-huh.
So they're communicating acoustically, 3 kilometers away through the water. So so basically you take a certain percentage of your slant ranges and how accurate the location is of the vehicles relative to the ship.
Got it.
Look at that cliff.
Oh, yeah, that's a cliff.
Yes.
Yeah.
It's the end of the world.
Yeah, ready to jump, guys?
Yeah, we might have to do a little jump on this one, I think.
Nicole, is that all right with you?
Yep.
Roger.
It's a very cool
Oh,
image.
yeah, some
Look
cool
at that
corals there.
Oh,
sheer
yeah.
coral at the edge.
Whoa.
Beautiful.
So Jessica, I know that one thing that helps you fly Hercules over the seafloor is something that you guys call the Z-bias. Do you have to turn that off when you jump off cliffs?
Well, no, that just kind of helps us to like be slightly positive in the water. That's a
Right.
nice feature.
Hey, Jess, watch out that there's another feature over here
Okay.
you might not see.
Roger. Thank you.
Yeah, I'm not seeing anything making me nervous in
Nothing
the sonar. See the cliff edge and Herc sonar. I don't see everything, so I can see the cliff behind Argus, not much in front, so we're
Alright.
pretty good.
I'm going
Copy.
to turn to your heading now, Josh.
Okay, I'll just try and keep the delta around a little below 20 and then see who picks up the bottom first.
Well, I'm going to hope.
You only got 3 beams right now, but
Oh,
about 25 meters off the seafloor.
yeah. There we go.
But we're good to 4 kilometers, right?
Yep.
You still have Doppler though, and you
Going
still have
down.
altitude, right? That's good.
Yep, we got 3 beams on the Herc Doppler at 24 meters.
All right. Going down, Josh.
Yeah,
Nice.
I just want to make sure that will come down
Far
too
away from
quick
the
on
wall.
me.
Looks like the wall's about 15 meters behind us.
Yeah, looking pretty good. Coming down.
Roger. I'll hold off here for a minute while you catch up.
Yeah, I'm coming down about 20.
Okay. Yeah, that wall's like 20 meters, or 15 behind you, 20.
Yeah, you keep scooting ahead.
Yeah.
So I was just wondering to, I guess either Nicole or Alex, what's the resolution of the sonar bathymetric map that we're actually working off at the moment?
I think this one's grid is 75 meters.
Okay.
It's the is this the Nautilus multi-beam, Alex? Do you know, or are we still on the AUV bathymetry? If we zoom out a couple clicks, I could tell. Actually, maybe this is the AUV, in which case it's a 5-meter grid.
Okay.
Yep.
So we have a pretty good idea of the bulk terrain that's ahead of us.
Yes.
Right.
Just gonna pick up something there.
Yeah, starting to see the back downside of the cliff. $10 meters off. All right, should be coming into sight soon.
Yeah.
Looks much more rubbly.
You're right, quite
Yeah.
different.
A lot more jumbled pieces than whole intact pillows.
All right, Nicole, I'll get myself set up and then in front of Argus, and then I'll turn a bit to face the slope a bit better for you.
Awesome.
Something like this work for you, Nicole?
Yeah, I think so. So you're, as long as we maintain the same heading, that's kind of what we're being asked to do on this.
Okay.
Yeah, we're
As we go
still,
along.
we're still, she's gonna kind of lateral a little bit.
Lateral
we're
along.
still
Yeah.
coming downhill a little bit.
Yep.
Yeah, I'm just
Yeah, it looks
gonna-
like there's kind of a series of steps here.
Yeah. Yeah, I'll maintain this heading and then I'll just slide around. As long as this view is okay for you.
Yeah, this is great.
Okay. Hello.
Seems like the terrain is making it challenging for you with altitude. Like it
Yeah.
catches different parts of rocks and tells you you're imminently close to the seafloor.
Yeah, you're gonna have to get going.
Yeah.
If you have to turn, you gotta turn. It's not gonna work. But
Roger.
So for those of you watching on Nautilus Live, Hercules and Argus are currently exploring the seafloor, approximately 2,900 and I guess 60 give or take.
Over 3 kilometers
yeah,
now.
we're like 3,050 at the moment.
Oh wow,
That's
well
right.
done.
Yeah.
We are 3,050 meters below sea level,
Wow.
And dropping.
exploring the Gorda Ridge marine feature. This is the location on the Earth's crust where the Gorda and the Pacific plates meet each other. and I believe this geotransect that we're on is actually leading us towards the real midpoint of the ridge. The Nautilus, from where you can hear all of us broadcasting to you from, is on the surface above the ROVs, operating about 180 kilometers off the west coast of North America. I think about 180 kilometers due west of, where is it? Point Orford in Oregon. If you want to get a more precise position, you can always check us out on marinetraffic.com, search for the Nautilus. That way you'll actually be able to see our transponder data.
Looking on Argus really shows a cool view of the terrain.
Oh yeah. So I think I heard the conversation earlier on our watch that had we turned on the Norbit sonar.
Yes, it's currently working.
Great. So although we can't see it accumulating, we're making a high resolution sonar map of this surface as well. Chris Krasnodski, or K2, is the Norbit specialist on board. He's not on watch at the moment, but he was explaining to us how, although the sonar works at a maximum resolution of 5 centimeters, often registering the maps and producing a final data product, it's normal to get about 20 centimeters resolution, which is still quite incredible. And because the sonar range is greater than our visual range with these lights, it really brings, it's not quite right to say daylight to the subsea, but it gives us a much broader perspective on the high resolution features that we can't pick out with our eyes.
There's a particularly fat fish right in front of us. Maybe just have it at a good angle.
Oh, crikey, I thought you were looking at the rock.
No, next to the rock.
Yep. There's some wonderful things. There's a glass sponge down at the bottom right, looks like.
Yeah.
And you were saying, Nicole, that yellow stalked sort of 5-petaled organism, that's an echinoderm of the family.
Yeah, it is. It's called a crinoid, a stalked crinoid. The more modern types have 10 arms. That must be a more ancient relative because it's only got the 5.
Right.
And some of them swim, not all of them though.
Part of the wonder for us on watch, and I hope for those of you watching on Nautilus Live, is that we're the first people to ever see this.
That's deep.
That's 3,050 meters of depth right there. Do you think the British accent adds another 100 meters or so?
I think so, yeah. For sure. Wow. A lot of life.
I think it was, I remember reading in Cindy Lee Vandover's book on deep sea hydrothermal vents. She's got a great opening summary chapter on the deep ocean, and I believe the phrase she uses that there's, although a lower abundance of life down here than in many places on planet Earth, there's actually as great, or if not a greater diversity of life in the deep ocean.
Yeah, this is a pretty neat area. Lots of different things.
Yeah.
Like a Dr. Seuss land.
Yeah.
To our friends from either Brazil or Portugal, I'm afraid my Portuguese is a bit rusty. So if you're able to, try me with I'll do Spanish if you want to send me that.
Just careful, you got a little bridge behind you there. You got to come up.
Yeah, Argus helps on this one, huh?
Oh yeah.
Oh yeah, totally.
See what's behind you.
Otherwise we wouldn't be going sideways.
Yeah, most likely not.
So what's our rate of progress, Alex? How far through the transect are we?
Target time is about hour 50. We have about 850 meters to go.
Okay, so we're still early days.
Mm-hmm.
There's another little ridge coming up. It's like holding your breath when you go into a tunnel.
So just a quick reply to our Portuguese or Brazilian friend. I stuck your text into Google Translate, and no, it never is too late to start studying oceanography. This is a great way to start to exercise your passion. And I'm glad you appreciate what we're doing.
Is that a black coral at the bottom left? Possibly, it looks like it.
What actually is a black coral, Sarah?
That one too, I think.
And don't don't pull any funny ones with me.
I only would recognize them by sight based on last year's expedition. I can't really define it because I don't know enough about coral to do that, but I can just try to recognize them based on their size and structure and color.
Okay.
Which are like not necessarily black, but darker browns, I guess.
Yeah,
The skeleton itself is usually dark.
I'm just waiting here to get.
But the polyps on it can be really bright.
Copy.
Before I go down and like over the rocks, right? So.
Wow, that's another really
cool.
steep drop.
Yeah.
I feel like I'm watching the abyss. I feel like I'm in the abyss.
This is when I wish I could swim down there. Yeah. Wow. Look at all them hanging off the side.
Yeah.
Whoa. Good thing Herc isn't afraid of heights or depths.
Oh, look at Argus view as it goes over the edge there. That's amazing. If any of you watching on Nautilus Live ever wonder why we have an eye in the sky, that's why.
I'll wait a minute before I start going down.
You're another 20 meters off the seafloor.
Yeah. I'll let you swing over a bit.
Yep.
So for those of you on Nautilus Live who are curious, we don't simply rely on the visual cameras to navigate around on the seafloor. There's a lot of sonar equipment on both Hercules and Argus that give us both a 360 view around the ROVs and also a view down to the bottom.
Let's see what this looks like. It's only 15 meters behind us. Went off.
Yeah.
Oh, it went over.
Just gonna keep an eye behind me for the wall.
Roger.
Don't see it yet.
It's a very straight feature.
Oh yeah.
The little crook in it, little bend in the elbow.
Which is the sonar on the right, Jess?
See the floor.
Is that you or Argus?
Roger.
That's Herc.
Okay.
On the
Herc,
right. Yeah,
yeah.
the bigger one. So it's just seeing a little crevice, little nook in the wall there.
Yeah.
Looks like it's 15 behind you now.
Yeah, I'm starting to see it. Yeah, I should have room. 15 off.
So for those of you on Nautilus Live on the quad view, you can actually see those
Looks like we're approaching a wall on this side here.
sonar returns on quad view channel 3, bottom left. Hercules is on the right, Argus is on the left.
Here I am, stuck in the middle with you.
We've still got 3 hours
I
and
can just
7
hear the
minutes to
music
go.
in my head.
Right.
Now you can see that little notch in the wall in Argus.
Oh yeah.
This one took a bite.
It looks like it was constructed.
Yeah.
I mean, the way it's very long and just tall.
Maybe someone built it.
Yeah. Poseidon?
Oh, there's another wonderful Argus view on channel 2 or
So I'm
quad
not
view.
sure about. Looks like it's a hole, and then it comes back up. But I'm not sure because I can't see anything.
Yeah, it looks like this is kind of pitted terrain. So,
Must just be rifted, huh? Super, like, rifted on both sides like that. And it's
yeah. Yeah, we'll just keep a good eye on the sonars.
Yeah.
Yeah, we're doing good.
This is pretty exciting flying.
Yeah.
Yeah, it's a little, it's kind of one of those situations where can't see a whole lot in the room, but that it's a little tense for the ROV pilots, making sure everything's going all right.
Oh yeah. One of those good moments to look back on, not go through.
Going downhill is a challenge for sure.
Yeah.
Especially when you have to maintain one heading. And actually, Nicole, if it starts to get like,
Yep, you could turn
Yeah,
if you
you
need
could-
to.
you can
I
even
can turn if I need to.
Yeah,
Like
I
if
think
it's sloped on the other side, you can even spin around.
I think it's better to get a visual. Shannon, you could correct me, but when we're going down this steep terrain, I would say it's better to get a visual so that there's something representing this location.
Okay. So it's okay if we change our
Yeah,
heading.
yeah. Just try and do the best you can.
Yeah, as much as possible, but the bigger thing, since we're looking at, in a lot of these cases, at the sediment accumulation, is the tops of stuff rather than trying to get into the sides of things.
Yep. Yeah, we're off the seafloor a bit, at least. It's hard to say. It says 8 meters altitude, but
Right.
I think that's at the very
The back of
back.
the vehicles.
Yeah.
Right. Because it kind of rises up in front of us. So.
Certainly looks like less than before. The sediment.
Now I was trying to look through my notes from Chris Kelly's talks about sponges and corals from last season. And I remember him saying that some colonize only the sediment and some need the harder surfaces. So is that part of what you're looking at as well, like the species, because they could indicate how much sediment there is?
That's interesting. I think if you're asking Shannon, I'm guessing she's not using that tact as her focus is on geology, but I think it would be interesting to share
Yeah,
this
I
video.
actually know virtually nothing about biology.
And I only know because I've been
So it
sitting
would
in
be
the
a
seat.
poor choice for me to try and do too much based off of that.
Wow, that's pretty cool.
Really
It's
cool.
a really beautiful
Little
terrain.
canyon there.
We're
You
not
got a
going up to
little
the wall.
nodule there, yep.
Yep.
Come up a little bit there.
Coming up. It's pretty tall, actually.
Yep.
Just go around it.
This is quite incredible terrain, isn't it?
It is.
It's really amazing.
Coming up.
Come up a little bit.
You get the sense for how dynamic this
Turn to
area
face it too if you want.
was. The fact that
Yeah, I'll
there's
try to
all of these
see if I can
rifts
maintain this heading.
and
Otherwise,
walls
just turn it.
of pillows.
Megan is a volcanologist, right, Megan?
Yeah, I'm studying volcanology and geochemistry in grad school right now.
Do you, with these dramatic features, be a result of like really quickly cooled or slowly cooled lava, or what?
Well, relatively speaking, lava that we're seeing here is cooled pretty quickly because of the really cold seawater that it's being erupted into.
Right.
So we're seeing in some spots some like really black, kind of glassy, exposed, where the sediment isn't covering as much. You can kind of see how black it is. But yeah, it kind of is interesting looking at the shape of the various pillows in different areas where it's really steep or more in kind of the troughs. It's hard to say, though, if the shape that we're seeing is, because a lot of them are covered up by sediment, it's hard to say, like, some of them look more like lobes or long tubes that might be covered up by more sediment. So it's kind of a really dynamic area, and Shannon probably will be able to speak more to this, but it's pretty hard to study sediment accumulation rates, to my knowledge, in a lot of parts because of currents, and to get an accurate sort of measure on time based on how much sediment cover. It's more like a relative kind of thing, I think, in a general area rather than an actual precise like dating thing. Maybe Nicole knows about that too, I'm not sure.
Yeah, that sounds...
Absolutely, you're spot on.
One of the cool things that I read about this area is that the estimate of like how old or how active they thought this part of the rift where we saw Sea Cliff was that it would be much older and therefore maybe less active based on the distance from the center of the spreading ridge. And so I think it's pretty neat to realize that some of these ways of estimating geological time, I mean, and timescales are just so big when you think of like Earth processes, that it takes a lot of different ways of looking at things to actually get an accurate assessment of something. That you could be kind of in the ballpark maybe, but still not understand some of the smaller scale processes that are going on.
I think I read some of the background literature as well. Was the estimate that Sea Cliff was based upon the rate of spreading from the center of the Gorda Ridge feature, about 100,000 years?
10-meter drop.
So I'm curious to hear maybe from Shannon a little bit more about the plans to connect what we're visually seeing in the video in terms of sediment cover and morphology and terrain with the rugosity of the maps, and how you're planning to kind of cross-correlate both of those sets of data.
So we've got code that we've been using for terrestrial and Martian applications that evaluates the rugosity of surfaces of lava. And obviously, you know, the other ones, terrestrial and Mars, you're talking about stuff that's dry. But it gives us something that we can go from the spatially distributed rugosity calculation. The rugosity is clearly different just in a simple qualitative visual look, just at the bathymetry data that we have in that great set from David Klagan and Bari. But we want to be able to actually run the numbers on that and then actually compare that to what's the percent inundation in any one of those sections from the sediment. The sediment is going to have a very masking effect on the apparent rugosity. It's going to smooth everything out. And we can actually then see if these things originally would have had similar things, how that's actually evolving with the influx of sediment. We don't know from any one of these points how thick that sediment is, but we can talk about how much of the frame of any one of these photos is covered by sediment. So we're doing some initial estimates right now, but we'll actually be writing some code to be able to systematically extract that and minimize the subjective error as we're looking through an absurd number of photos later.
So I guess the systematic part of it with the maps makes a lot of sense because you kind of have coverage over a whole area. But since we're kind of going along a line through just one part of the whole map, are you planning to kind of use certain areas as representative visual sediment covers and match those with the rugosity seen at that same area in the bathymetry to apply that to a larger region?
So we're going to be trying to do point comparisons where we can, but obviously as you're just driving around on these lines, there's a limit to how much we actually have and how much we can see. So we're also trying to just get some characteristic curves of what is reasonable or typical for these different shelves. And those curves are going to overlap in space, but they should actually hopefully provide some more distinct separation than just all being the same thing. So like here, if you look at the stuff, we're actually not seeing a lot of sediment. We're seeing a lot of really small rocks, cobbles, stuff that we weren't seeing way upslope in some of those other areas where we had flat zones, similar slopes to this, that had a lot more sediment fill. We've just got some small patches of it going on here. It's going to be imperfect. I mean, we're talking about, you know, some rough cuts, But the flip side is that we have some spectacular imagery and some just amazing bathymetry data. The stuff that we've got from David Klagan and Bari is at 1 meter resolution, which is just unbelievable for being this deep and in a really interesting patch spanning these different bathymetric steps.
So any day when I learn a new word is a good day. So I was just wondering what rugosity means.
That's like, it's like
Rugosity is a measure of roughness.
Okay. Thank you.
So something that is really smooth and flat is going to have a different rugosity than something that's got a lot of up and down. So one of the ways that we can measure rugosity is to consider measuring the actual surface area of one of these patches, all the up and down, versus just the flat map area of it. So in a square meter, if you looked straight down, what would the actual surface area be contained within that square meter? And we can set that up as a ratio, the 3D to 2D areas.
So greater surface area per unit area is a higher rugosity.
Yes, that's correct.
Cool, thank you. I was just intrigued, Shannon, by the comment you made about you do these studies on Mars as well. And I was just wondering if you can do those kinds of studies using, is it satellite imagery on certain scales, or are you actually using imagery from the surface rovers?
Based imagery, we're actually using digital terrain models from the HiRISE system up there.
Okay.
And that's because of the angle of view that we're using. So looking down on something, actually having a 3D raster terrain, so continuous data, is going to give us some things that we can actually analyze a lot better than something from a rover, where we're going to have a lot of problems resolving the changes in the field of view, like how far away something is. That old thing from that movie about, is this a really tiny cow or is it very far away?
Okay, yep.
Anyone know what that white thing is?
Lower like a dying sponge, maybe.
Yeah.
I was just going to say thank you to Sarah, our video engineer. I think it's been at least an hour since I've had a piece of chocolate, so I was going into I was going into a little bit of withdrawal there.
Oh no, I'm glad I caught you just in time.
Withdrawal.
We need you on top of your game.
Awesome. Yeah, I'll take that.
I was going to say, Josh, I've been watching you through the various shifts. You've got willpower of iron when it comes to chocolate.
It's about to break.
Oh, yeah?
Willpower of iron.
It's the evening watch.
Okay.
Yeah.
It's dessert, honestly.
Ooh.
Nice chasm.
Wow.
Fisher?
As John was saying earlier, it just really is so cool thinking about what this was like as it was being formed. Like, I don't know, just the whole thing and movement and change. I don't know, just so cool.
Well, I was reading in the literature, this is a really interesting plate boundary, the region where we're operating in, because I believe it was 1990.